Video number 148, finding function values of an angle. Now in this video, similar to that in 147 and 146, what we're doing here is we're going to be using sine, cosine, tangent, cosecant, secant, and cotangent. It's very similar to what we've already done. This is basically, we're going to graph a line. Okay, so we're going to graph a line, and then we're going to find the 6 trig function values of the angle in standard position, basically meaning the reference angle if the terminal side is defined by this, basically greater than 0, so meaning x has to be over here. So we're looking in quadrant 1 and or 4. So let's go ahead and graph this. We all know this is definitely y equals negative 3/5 x, so when we graph this, we're looking at going down 3 over 5 for the slope of the line. That gives us 3 here, 5 here, let's cross that out. And then our hypotenuse will be done by doing the Pythagorean theorem. So 3 squared plus 5 squared equals c squared. C squared equals what's 9 plus 25 is what? 34. So c equals root 34. Alright, we need that to get to use the hypotenuse, right? Because sine is opposite over hypotenuse. Where's theta? Right here. Alright, theta is the reference angle, drawn right in there. Not turning out too well. There we go, theta. Alright, opposite over hypotenuse is going to be 3 over root 34. And then you're going to need to take a look perhaps at another video of rationalizing the denominator. We're going to multiply by root 34 over itself. That's going to give us 3 root 34 over 34. That's going to be the sine value of that angle. Cosine is going to be adjacent over the hypotenuse. So 5 over root 34, which is going to become 5 root 34 over 34. Tangent is going to be opposite over adjacent. That's going to be what? 3 over 5, which gives us 5 over 3 for cotangent. And then from here, we're not going to flip this one over. Let's go back to the original, because cosecant is the inverse of sine. So now we're just simply going to have root 34 over 3. Secant's inverse cosine, so root 34 over 5. And that is pretty much it, except what? The 3 is definitely negative. What do we know about quadrant 4? We're definitely dealing with the fact that sine, cosine, we know tangent is definitely a negative because sine is negative and cosine's positive. So we need to go back through here and take care of business. Sine's negative, so squeeze a negative in there. Cosine's positive, so this one's good. Tangent's negative, so bam, there you go, negative. Alright, now the inverse is definitely going to be negative, right? This is a positive. If it flips over, it's still positive. This is negative. If it flips over, it's definitely negative. So either way you want to slice it, if you want to put the negative 3 in to start and kind of work with it, or you can just double check afterwards your sine, cosine, and tangent in that particular quadrant. Alright, next one. We have negative 3x plus y equals 0. X is less than 0. This is basically the same problem, except we have, let's see here, looks like this is y equals 3x, so we're looking at a slope of up 3, and it would have been to the right 1, but what are we looking at? X values, the domain is definitely negatives. So we're going to have to go back this way. That gives us a, let's see here, we're going to look at, let's go to this point here and do this reference triangle, a height of 3 and a 1. Okay, so then we're just working with this. Obviously, the Pythagorean theorem, 1 squared plus 3 squared equals c squared. C definitely equals square root 10. Okay, so what we're working with is, let's go ahead and try to zoom in a little bit, if you will, on the situation. We have root 10 here. This is a 3, that's a 1. So theta is definitely over here. Okay, so opposite over hypotenuse would be 3 over square root 10. Cosine would definitely be 1 over square root 10. Tangent would definitely be 3 over 1, which is 3, making cotangent 1/3. There you go. And this one here would be just simply root 10, and this would simply be root 10 over 3. Let's rewrite this root 10 there. There you go. Rationalize the denominator. Multiply by root 10 over itself. And make sure you check the video simplifying radicals if you need to. That's definitely on this blog. 3 root 10 over 10. And this is definitely simply equal to square root 10 over 10. Alright, so there's your 6 trigonometric function values. Of course, what did I just forget to do almost? Both the 1 and the 3 are negative here, meaning that sine's definitely cosine's negative, sine's negative, and tangent would be positive. So these two guys here are positives, and then these guys here are definitely all negatives. Okay, there you go. All right, questions or concerns, please send me an email, and of course, good times.